Okay, good morning. I'm planning on doing weekly contest 285 from last Saturday virtually. So here we go. All right, open these guys up. Give me 0 index array nums. Index I is part of a hill of nums. If the closest non-equal neighbors of I are smaller than I. Similarly, the index I is part of a valley of nums. If the closest non-equal neighbors of I are larger than nums of I. Adjacent to I and A are same hill or valley if nums of I equals nums of j. Note that for an index to be a part of the hill or valley, it must have a non-equal neighbor on both the left and the right. Return the number of hills and valleys. That's a hill. That's a hill. Hill, and then this guy is a valley. Okay, so let's do this. 6:15 a.m. is when we start. See, filter the input array A into unique values for I in 1 to n minus 2 inclusive. Increment count by 1 if and only if a sub I minus 1 is strictly less than a sub I and a sub I, right, it's greater than its 2 adjacent neighbors. Otherwise, if it's less than its 2 adjacent neighbors, strictly less than, right, then we'd also increment the count. Okay, so let's do this. Var A equals A underscore dot map, or not dot filter. I wonder if we can create unique. Yeah, let's just do this. Var scene goes mutable set of int for x and a underscore RA equals mutable list of int. These will be our unique values. If not seen, that contains x, scene.add x, and then we'll do a dot add x. Okay. For I in 1 to n minus 2 inclusive, that's 1 non-inclusive, n equals a dot size, count equals 0, return the count at the end, count, let's see, if a sub I minus 1 is less than I, and a sub I, a sub I plus 1, let's count, and then let's do this also for the other condition, where a sub I is strictly less than its adjacent neighbors. Uh-oh. Let's see, a dot size minus 1. 3, and then it should be 0 for the other one. Looks good. Uh-oh. Okay, so 6:15, 6:18, oops, 6:18. 3 minutes. Four. Wrong answer. Okay, let's see what's wrong here. Expected 1, but got 2. Okay, this is the 1. Okay, so the peak. Adjacent indices I and G are same hill or valley, so why is 7 not a peak? And note that for an index to be part of a hill or valley, it must have both the left and right. Yeah, that's fine. Why is, right, the question is, when we remove the redundant values, basically this comes into this, so question, why is a sub 1 equals 7 not a peak? Why is a sub 2 equals 1 not a valley? Right, a peak or a valley, or hill, valley, hill, right? I'd expect this to be 2. I thought 2 was correct per the problem statement. Let's read the problem statement again. And maybe I solved the wrong question. If the closest non-equal or smaller, right, it's a valley, they're larger. They need to be adjacent, not just seen. I see. Okay, so hold on. Our last equals -1, last equals x. If last does not equal x, a dot add x. Excuse me. So, I mean, that's still not right. It's still going to be 5717. Why is that 1 instead of 2, though? It still doesn't make sense. One, two, closest non-equal neighbors. Index 2 is a valley, 0, 1, 2. This is the valley. It's part of the same valley. These are the same valley. What the heck? This doesn't seem right. It should be 2 instead of 1, right? And 1 hill there, 1 valley there. That's 2. What the hell? What am I missing here? Non-equal neighbor? Is that why non-equal? So what is this Leetcode? Is it ambiguous because 7 and 7 are the same value? If so, FU Leetcode, one of your stupid ambiguous problem statements. And a sub I minus 1 does not equal a sub I plus 1. A sub I minus 1 does not equal a sub I plus 1. What? Output, wait, hold on, did I? Oh, I'm outputting 1, I'm expecting 2. Okay, so how is this not 2 then? Okay, so it should be 2. Okay, I'm just totally confusing myself and wasting time. Damn it. It should be 2 then, right? This is 2. The hell? How is this the wrong answer if this is coming up as 2? Output 1, expect 2. I'm not outputting 1, I'm outputting 2. What the hell did I miss? Okay, what a waste of time. Ugh. What a stupid waste of time. Confusing self, I suppose. And scene is fine then, right? So scene, mutable set of integers that have been seen. Scene that contains x, add x. Oh, okay, so that is wrong then. The way, okay, so that's where I was going wrong. Okay, so that 7 at the very end was not there. Okay, that makes sense. Totally confusing myself, and obviously I'm still a little bit confused. All right, let's do this. Oh, this is good. Okay, that's fine, right? Just like that. Okay, let's move on. This is not an algorithmically complex question. And yeah, okay, well, let's just bust this out and get to the next one. Turn the count. Oop, and then last equals -1. Okay, so for x of a, if last is not equal x, then let's do this. Underscore let, or how about this? A is an array. A dot push x last equals x. Okay, then for I equal 1, I is less than a dot length. All right, if a sub I minus 1 is strictly less than a sub I, a sub I is greater than a sub I plus 1, then 1 comes into count. Do the same thing. It's strictly less than its adjacent neighbors, and then call it a day, right? Okay, let's post this and get going. Few solutions. filter the input array A such that adjacent equivalent values are I guess filter the input array A to remove adjacent redundant values, right? Then perform a linear scan of this filtered array to accumulate the count of hills and valleys. Kotlin, JavaScript, Python 3, Rust, C++. Okay, so JavaScript, Kotlin, all right. Python 3. X for X in A underscore if enumerate I or a sub I minus 1 is not equal a sub I. So filter that thing out. A sub underscore for I in range 1 to length of A. If a sub I minus 1 strictly less than a sub I and a sub I is greater than a sub I plus 1. Count block equals 1. 0. Return the count. Increment the count for the opposite direction if it's strictly less than its adjacent neighbors. Oh, count length of I non-inclusive. So it should be 1 to n minus 2 inclusive. Right, that's good. Okay. Rest type VI, specter of I32s. Underscore, let mute A equals vector. Filter from A for X in E underscore. Mute last equals single 1. Last X. Last not equal X. Then A dot push X. Right. Oh, let's stick it on a different line, whatever. Okay, and then for I in 1, 2, A dot length minus 1 non-inclusive. return the count to the end. Let mute count 0 if a sub I minus 1 is a sub I and a sub I is greater than a sub I plus 1. And count equals 1. And that's same thing for the opposite equality. Okay. Looks good. Looks good. Stick this here and move on to C++. Jam this out real quick. Oops. Okay, and last, think 1, count 0. Count in the end. And then this will be API filtered array auto x a underscore if last is not equal to x, then a dot push back x last equals x or auto I 1 to n minus 1 not inclusive. I don't want to subtract 1 from a unsigned integer because it's always sketchy, I think. Works. Okay, so if sub I minus 1 is a sub I strictly greater than sub I plus 1, increment the count. Also increment the count for the opposite equality. Okay, looks good. Looks good. Looks good. Okay, post this, move on. Bam. All right, filter the array. Oops, filter input array A underscore, right? To remove redundant values. Right. And perform a linear scan of the filter array. Let's put A here. To accumulate the count of hills and valleys. Looks good. Okay, so that took 23 minutes. Okay, so Q2, 6:36 a.m. 6:36 a.m. is when I'll start. Okay, here we go. In cars on an infinitely long road, 0 to n minus 1, left to the right. Given a zero index string directions of length n. Directions of I can be either L, R, S, denoting whether or not the ith car moves left, right, or staying in its current position respectively. Each moving car has the same speed. The number of collisions is calculated as when two cars move in opposite directions collide with each other. The number of collisions is 2. When a car has a stationary car, it's 1. After a collision, the cars involved can no longer move. I'll stay at the point where they collided. And that cars cannot change their state or direction of motion. Return the total number of collisions that will happen on the road. Okie dokie. So the collisions that will happen on the road are based on the problem statement. So it sounds like we can just do a simulation of the problem statement and then accumulate the number of collisions as we go. All right, so this is our string. So 1, 2, 3, 4, 5, 6, n equals 6. Okay, so this one goes to the right while this one goes to the left, so that should count as 1 each, right, for 2 total. This one goes to the right, and that's stationary, so that'll count as 1. This one goes to the left, that stays stationary as 1, and this one's 0. Wait, hold on. 0 and 1 collide, so that's 2. Okay, got those. 2 and 3 will collide, right? That only counts as 1, though. 3 and 4 will collide. That only counts as 1. how is it that 4 and 5 collide with each other? Four and 5 will collide because after 4 hits 3, we'll get hit by 5. Okay, so that counts as 1. Stationaries are 0. Okay. It seems like we should be able to pre-process the input string from left to right and right to left and know what's to the left of each and to the right of each in order to calculate whether there's a collision or not. So if his LLL, there would be no collisions. Right, so whereas SSS, there'd be no collisions as well. So collision if and only if some rights, right, there exists a car on the left somewhere, right, or some I, J, right? And I guess there exists an ith car which runs into some j car on the right. So this can occur when the ith car is S and jth car is L, or the ith car is R and jth car is S, or the ith car is R and jth car is L. So this one cost 1, this one costs 2. There's some subtle trickery to this one for sure. Let's see, so I don't think it's that simple because there is adjacency that's taken into account. Right, so if we have, let's say we have LRS, LR, and that should cost 2 and 2. Right, this one is 0. I don't think that one would be involved in a crash, right? So you have to keep track of where the crash begins and ends. Like, where do you crash? R goes into that guy. L. Wonder if I can use a stack. Push. What do we do? We could push R's and then pop them to get an L or S. And if we push the R and pop with the L, that costs 2. Pop with the S. I wonder if we can use a stack and then process it from left to right, and then use a stack and process it from right to left. So if we do it from right to left, then L, L, that one runs into that one, runs into that one. Wonder what happens when L, L, R, R. Okay, no cars will collide with each other in that case. So the ambiguity exists when there's a crash. What happens after that crash, right? So left runs into stationary, the other left runs into that one too. Okay, so we'll count the number of lefts as we go. 1, 2 to the right. 1, 2, 3 to the left. Okay, I think that works. Okay, I think this works. Use a stack and push pop for reductions of collisions, which increment the count, right? And to be returned. And perform this from left to right and from right to left. Okay, let's give this a shot and see what happens. Okay. Function f, let's say, and we'll go from I to j. How about? And this will return count. Okay, so turn n equals s dot length. F sub 0 to n minus 1 plus f sub n minus 1 to 0. Right to left, left to right. I think that works. Hold on, let's do this. 6:36 to 6:48. It's about 12 minutes for game plan. And then the actual implementation starts at 6:48 or so. indentation. Okay, so if I is less than j, then r. Okay, so one we're gonna take, and then we're gonna reduce. So add and remove. Let's call these things push and pop. How about push pop equals, if I is less than j, then we're going from left to right. We want to push the rights and then pop the lefts. Or push. Oh, okay, actually, let's just do this to target, right? Target. Be right. Actually, let's do this. Yeah, push and pop is okay, right? Push pop, we can just make these as sets. Pair. It's not a mutable set, but it's just set. Okay, so we're gonna push right? Set of R, set of LS. Otherwise, pair of set of L, and we'll pop set of RS. Okay, so for C and S, if the push dot contains C, otherwise it'll pop. Yeah, that makes sense. Okay, so let's just do this. Push without the pop. Push it onto our stack and then pop it off. Stack, our stack equals mutable list of. Or do you just want to keep track of a count as we go? The count of R. Let's do this target. How about our target? Target is R. Otherwise, target is L. If the character is equal to our target, then we'll increment the count. And then when it's not equal to that, we pop those counts. I don't think we need a whole stack because when one collides, they all collide, right? Count equals 0. And then the total count maybe? Total count equals 0. Okay. Total target character. Increment the count every time it's equals a target character. Otherwise, if it's not, then the total equals count. Count is reset back to 0. Left to right and right to left. It's not right. Not at all. Left equals this guy. Right equals that guy. R or return. Let's print this out and see what's going on here. L R. One reduction there, one reduction there. Increment the count to 2 there, 1 here. So right to left is not correct. Ooh, that's why. Okay, because I'm doing this from left to right. Okay, so I is less than j. So while I is less than j, less than or equal to j. If that's the if target is right, we want to use I, right? And S of I target equals S of I. Okay, so something like this is what I want to do. All right, so if it's right, then we'll want to go I wonder now if I want to do this like that or just do 2 separate functions. Left to right and then right to left might be just easier to try 2 different functions, right? See, left to right, we're looking for rights. character equals right. Uncomment the count. Return the total in the end. Total on count. R is the same thing in the other direction. Return the total count for C and S dot reverse. If C equals L. Oh, actually, let's do this. Let's pass in the string. How about this? Let's call this thing a function. A string and a target. How about target is a character. The character equals the target. Return the total. Okay, so the string will be S. In this case, the target will be R, and this is S reversed L. Okay, that looks pretty good. Looks right. The other one's 0. 5 and 0. Looks good. Looks good. Okay, 648 to 701. 13 minutes. This is a little bit tricky, but not terribly too complicated, right? So use a stack to reduce it based on the count. And then reach the target. Do some reductions. Okay, so let's do this in the other languages, then we'll move on. Right, nothing too fancy. Do I even need in? No, I don't think so. Okay, that looks good. All right, let's do this in the other languages here, and then push it on the discussion board, and then move on to Q3. G solutions, and of course, stupid guys that are complaining, get all the upvotes. Ugh, what junk there is on the discussion boards these days. Total bummer. Oh well, I'll focus on the leaderboards, not the discussion boards. Since when did popular opinion know anything? Upvotes are nonsense. Okay, yeah, instead of complaining, let's actually focus on our coding skills and stop sucking at coding. How about? Yeah, Leetcode's done way downhill, unfortunately, but whatever. I don't have to go downhill with these folks. I can continue to rise. So let's do this. Let f equal our string and our target. And then we can return f sub s, and our target will be r plus f sub s dot split dot reverse dot join. Or is s dot made reversed? I don't know if there's a reverse function or not. I guess you want to use a stack and reduce this guy. But actually not stack, but a count, right? Total count 0, 0. Return the total of our count. So our count would be the size of the stack, the amount of cars that are going to collide. So for let C of S, if C is equal to our target, then we'll increment the count. Otherwise, total equals our count, and count is reset back to 0. Okay, that looks good. Uh-oh, S is not defined. S is our input string. S dot reversed is not a function. Okay. S dot split. Dot reverse. Dot join. Okay. There we go. Looks good. Okie dokie. Python 3. All right, let's do this. Def string target total count. Return our total of our counts for C and S. If C is equal to our target, then count is incremented by 1. Otherwise, total is incremented by count, and count is reset back to 0. Right, and then we're going to return f sub s. Target is R plus f sub reversed s l. Oh, count goes 0. Looks good. Looks good. Okay, Python 3. All right, rest in C++, and then move on. String fn f, s is a string, t is our character, which is our target, and I'll return I32. Return f sub s, target would be R plus f sub s, and our target is L. Okay, and let's mutable t, mutable count goes 0, 0, destructured, and we'll return t for c and s dot chars. Into iter. Just iter. Okay, so if C is equal to our target, then count equals 1. Otherwise, our total count is incremented and count is reset back to 0. No, maybe then make iter into iter, or just chars. Maybe chars is just good enough. Moved value s. So okay, hold on. Let's do chars. S dot chars. C and S dot chars. Copy trait. Oops. S dot clone. That reversed. I wonder if that works or not. There is no reversed. I wonder if this works. Will it compile? Should return 3 and 0, or 2 and 0, right? Okay, so that does work right. Now I need to reverse the string. Rest, reverse, string, reverse string and rust, chars dot reverse dot collect. Okay. Plus f dot chars dot verse dot collect. Borrowed here, f. Borrow it? Does this work? Reference to a string? Yeah, okay. That's cool. Okie dokie. A little rusty on Rust still, but getting there slowly but surely. And then C++. F is our function. Capture S by, no. Pass an S by my R value reference. So wanna, it's okay. No, yeah. R value reference sounds good. That way I can do the reverse range auto target or auto reach character or auto T count equals make pair 0, return the total of our counts for each character and input string S. If character equals our target, and we'll increment the count by 1, otherwise total add onto our count, 0 out the count. Okay, and then return F sub. Start again. Start in. Target will be R plus F sub. F to R begin. F to R end. Right for reverse. Reduce else. No matching function. What? Oh, wait. R value reference string. What? Current refer input type auto. Really? Why not? Here, let's do this. Fun using fun equals function returns an integer, right? And has a R value reference for that, a character for that. Looks good. Already post this and then move on. Okay, yeah, so that's cool. And we have 32 minutes left. Okay, so these taking me about 30 minutes each. Got a lot of room for improvement, but whatever. I mean, yeah, these look pretty okay, decent, right? Oops, I need to add a description, right? Process the input string S from left to right and from right to left. We two-pass solution, right? Left to right and right to left, right? Reducing the, I guess accumulating the total T count of collisions in each direction. Hey, buddy. Hey, partner.
Dad, I have 40 minutes to spare.
Yeah, I got a little bit of time. I'm doing a virtual contest right now, Sam.
Does that mean like one like practice one?
What's that?
Does that mean like a practice one?
Yeah, this is a practice one. I guess they're all practice. No, I love to teach that. Good one. Look at that. All right, two-pass solution. All right, process. I don't need to put that. Whatever, you can see it goes from left to right, right to left, right? Process the input string from left to right and right to left, accumulate the total T count of collisions in each direction. So, yeah, that's fine, right? So yeah. Nah, right, I don't need to spoon feed people. Either you know how to code and you can read code or you can't, so whatever. Okay, so yeah, 30 minutes left, and yeah, let's go. Maximum points you can archery competition. Alice and Bob are opponents in archery competition. The competition has the following rules. Alice shoots first, or first shoots num arrows, then Bob shoots all of them. Okay, so you shoot all in. They shoot all in. All 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is bigger. Oh, okay, 0 to 11 non-inclusive, so you shoot 12 total. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so there's 12. Each section of the target with score K between 0 to 11. Say Bob and Alice shot A, so K and B, so K arrows on each section, respectively. If Alice is greater than or equal to, then it takes it. Otherwise, if it's less than or equal to, then Bob takes it, okay, and no one takes it. It is 0 because scoring section. The sum of the values in Bob arrows should equal num arrows. So it should be 9 total. Bob wants to maximize the total number of points you can obtain. So if you want to maximize it, then Alice is greater than or equal to it, then Alice takes it. So you want Bob to be strictly greater than Alice. Bob should be strictly greater than Alice if possible for the maximum. Alice's arrows if it's 0. Okay, so we greedily want to use the number of arrows such that Bob exceeds Alice by 1 in the largest positions. So it seems like it makes sense to sort, or no, go from right to left, right? Because the scoring positions are 0 to 11 inclusive. Right, the score, this is the biggest score, so we want to cherry pick from right to left. I think that makes sense, right? Okay, so we have a little less than 30 minutes remaining in the contest. Okay, so the game plan is to process the array slot greedily from right to left. That'd be from 11 down to 0 inclusive, right? And then now Bob has multiple choices actually. Num arrows 25 that can be consumed. Okay, so this looks like dynamic programming because the multi-stage decision process, right? Previous choices affect current choices. Okay, I got 24 minutes left. So I don't know if I want to jam on this or go walk my kids to the school. I think I'll take a break and watch my kids to the school. And that's the game plan, I think. Yeah, this looks like TP to me, since it's a multi-stage decision process. So that we can Bob can accumulate the K score from 11 down to 0 inclusive. At each stage, Bob would use scoring section A sub K plus 1, right? So A sub K represents Alice's arrows, right? And you need one more arrow to win, right? Arrows to beat Alice's Ace of K arrows. Then Bob would have X minus Ace of K plus 1. Oops. Arrows remaining for the next K score. So I guess there's like two choices, right? So there's basically two choices. One, all right, we include or exclude, right? Basically include, exclude. For each Ace of K from K equals to 11 down to 0 inclusive. Okay, we should be able to write down the top-down solution, I believe, at least, right? Ace of K plus 1 arrows. Yeah, it should be fine. So this is how many we have? X. Sorry, input array. Go. How many arrows we have, or K capacity, I guess. K can be our capacity of arrows. K is an integer. And then our I position from 11 down to 0, from 0 down to 11. Either way's okay. Giving K arrows. The optimal choice for those to include or exclude. Five, 6, 7, 8, 9, 10, 2. So Bob gets 11. Which ones are good for Bob? That one. 11 points, 10 points. Oops. Let's do this. Carrots, how about that one's cool, that one's cool. That one's cool. That one's cool. That one, that one. So what is it then? 11 plus 10 plus 9 plus 8 plus 5 plus 4, 47. 47, okay. That's the optimal choice. So instead of spending 3, 2 to get here, 4 is better than, or 9 is better than 7. Turn and go. Best of include and exclude. If I is equal to n, and dot size, then we'll return 0. Make no points once the array is exhausted. Otherwise, var include equals if k exceeds or is equal to, no, it needs to exceed a sub I. Then we can include it. Include to be the value of k. Or I, right? Include equals I. Will be I plus go I plus 1 k minus a sub I plus 1. Exclude would equal go I plus 1 k. If k arrows exceeds a sub I, that makes sense. Okay, so then return the maximum of include and exclude. I equals 0 and k equals k. Inter is expected. Oh, I need to keep track of each individual choice then. The optimal choice for each selection. Let's see, println answer, and then let's see, return int array. Let's just return an empty int array for now, just to check if my sum is correct. Should be 47, right? Okay, so that is correct. So now how do I go back and say, okay, this was the optimal choice, was to include, or this is the optimal choice to exclude. So if include or exclude is less than include, then we can push it onto the map, right? As the recursive stack unwinds, we choose the optimal choice. Go, and then return the answer, right? Return the answer. Oops. Return the answer. The int array size in. Those are all zeros. If include exceeds exclude, then we'll say and sub I equals how many arrows do you need to use? A sub I plus 1. All right, we have to beat Alice's arrows by 1. Okay, let's see what we got here. That looks legit. Okay, and then if we add a memo on top, I believe that should avoid TLE. Let's see, this is expected TLE. TLE, oops. Oh no, it's the wrong answer. Okay, so this is not even the correct solution. 9, oh no. Your input, your answer. Expected. Okay, so this is not right. Answer, I put a 2 here. And then a 1, 1. So this one's not correct then. Should be 0, but it's 2. It's 5 plus 1 is less than or equal to k. 0, then it has to be 0. Why is this one coming up as 2? Include, exceeds, exclude. Shoot, 1 plus 7 or 1 plus these guys. I don't think the order matters, right? You can go 0 to 11 or 11 to 0. Either way is fine, right? Pi equals -1 to 11 down to 0. Should be the same thing, right? Oh, dang, that is 11 down to that gives me a completely different answer. Okay, something's not quite right here. Eek. It's more natural to go this way, right? 0 to n. But then why is this 2? Got 9 minutes left. So why here, right? Question to self, Christino, why is a sub 7 equal 2? I mean, even it should just be 1. Alice score is 0, so Bob would use at most +1 of that, right? Why is it doing +2 of that? That makes no sense whatsoever. A sub I +1. Oh, it is 1. It's 1, okay. So you do need a 2, but then you'd run out. Right, 9 exceeds 7, so that's why we choose these instead of that. Should be 9 total, right? 1, 4, 6, 7, 8, 9, and then we'd be done. K exceeds a sub I +1. Then we can use it. But it's better to exclude it with all k remaining intact. Exclude it, right? Once we exclude it, it should equal 9 instead of 7. So okay, this is the wrong answer. It's really strange, this question. I thought it would work okay to go from 11 down to -1. Like, I'm surprised this doesn't work. Oh, maybe force exclusion, negative infinity here. Maybe that's what I want. To force exclusion, hold on, let's go back to this. Force exclusion, maybe that's it. No, that's still, what the heck, man? Like, why is that? It's not keeping track of k correctly because it should be decrementing as it goes, right? 1, 4, 6, 7, 8, 9, and that's it. K is exhausted. heck? And okay, right now, obviously I'm missing something pretty basic. Why is this a 2 instead of a 0, right? Include exceeds exclude. And that's not possible. As the recursive stack unwinds, 4 plus 5 is 9, and this is 7. So how is it that well, is it local include then? Local include and exclude? Like, you're always going to want to take I rather than exclude it then, right? But it needs to be all that stuff like that way and this way. So maybe order does matter. I should go right to left instead of left to right. And I include. Yeah, now I'm just playing with stuff just to see what will stick as I throw it up on the wall. Right. See, that's the strangest thing. It's like when I go from right to left, like I get a whole bunch of stuff I'm not expecting. And fundamentally, my recursion is missing something because I should only use up to 9. Okay. If K doesn't exist, hold on. If I go 0 or K, all right, I understand, right? Or K is 0, I need to return 0 immediately, right? I shouldn't keep processing. Like, how is it this even possible? Like, optimal local solutions, holistic solution. This is a good question. I'm totally spent, right? I mean, obviously missing some pretty obvious stuff here. So yeah, let's take a break, right? Take a break and absolve later. But it is dynamic programming, right? It's multi-stage decision process for the current stage choice adversely affects subsequent choices. So you take into consideration all choices and return the optimal choice. Okay, exceeds that, and I plus that, otherwise. Yeah, okay. Sometimes I don't want to, but it's best to take a break and come back fresh. And you have 54 seconds left. I don't think I'm going to solve this thing in 54 seconds. This is the brute force, right? I need to still add a memo, and then if the memo TLEs, I need to turn it upside down, right, to bottom up. So definitely have a lot of room for improvement on the dynamic program. And I get the general gist of it. I can recognize, okay, this is a dynamic program problem, but the actual implementation, I've fallen short, obviously. So that's cool. That's cool. Whatever. It's cool. Yeah, whatever. Let's upsolve tomorrow. Right? Whatever. However long it takes. All right. Get you next time.